Again, guys, I can't. I have given you the list of problems I officially assigned from the text. You don't have to do them or turn them in. Same problems are available on MATLAB. I know I'm repeating myself. It's for people who missed the first class, okay? So if you do the MATLAB problems, you will be fine. And these are the same problems, but these are from your book. The screen that you're seeing in front of you is basically a screen capture of our text, 2.1, section 2.1. So be aware of that. I'm going to do a couple of problems. And what are we trying to do? Well, we're going to use one of the two formulas. Okay, I'm going to first do a very simple one. Okay, where the radian will be, where the angle will be given in radian. Then I'm going to do one where the angle will be given in degree, and you have to convert it. So I'm not going to tell you which one I'm using. Well, I will eventually tell you, but let's not worry about the formulas yet. So I assigned some of these here. So what are they saying? Let me do one thing. Again, guys, you want to read. You always want to read the full text. I know it kind of is cutting off a little bit, but just to emphasize that you do need to read it. Okay, not bad. It's not cutting too bad. Okay, let's read it. A denotes the area of a sector of a circle. R is the radius, and the central angle is theta. Find the missing quantity. Okay, which one do we do? Well, we're going to do a couple. Let me see before I do it. Let me do this, guys, if you don't mind. Okay, it's the same thing. Okay, this one wants you to find S and R, and the only thing I want to be alert about is if the angle is given in degree or in radian. If it's given in radian, you're in good shape. Okay, so let's do one. Let's do an easy one first. Okay, let's do 72, right? So, all right. I hope you can see it's not too small. So this one, it's not bad at all. The R is 6 feet, theta is 2 radians, given in radians. Good news, S is something you need to determine. So you're going to say, okay, the arc length S is R theta, given theta is in radian. And okay, what's R? 6. What's theta in radian? 2. The answer is 12. Now, it's a good idea to write the unit. On the exam, I expect you to write the unit. Remember, arc length is simply a length, how long, how tall your height is, how long a ribbon is. So it's the length. So it should be feet. Why is it feet? Because the question has feet for radius, the same unit you will do. So that's my 72, done. I generally pause a little bit, okay? See if people have any questions. All right, guys, let's do one where the radian is not given in terms of, where the angle is not given in terms of degrees. So let's try number 78. All right, again, the theta is given in terms of 120. The first thing I need to do is convert 120 degrees to radian. And remember how we did it last time? So it's a little bit of review. I do know one thing. It doesn't matter which one you write first. I'm just going to write this time pi. I'm not going to write, well, if you want, I'll write pi radian. Doesn't matter. Pi is 180 degrees. Okay, that's something I know. Now, what do I want? I want this side. I want the right-hand side to be 120. So I go through one. I divide both sides by 180. Okay, and that's good news because that's one. 180 divided by 180 is one. I'm going to go here. 1, and you really want to be accurate, it's 1 degree. So I know 1 degree is pi over 180 radian, but I don't want 1 degree. I want 120 degrees. So you multiply both sides by 120. 1 times 120 is 120, and you have to do it here too. Okay, a suggestion would be to do some of these things by hand and cancel and not use your calculator. And I'm not saying it just to make you work hard. Your math will be better. You will be able to write the answers better and all those things. So I'm going to simplify this. I'm going to explain it to you like this. I can cancel the zeros. Okay, they go away. I can divide 12 by 6 and I'm going to get 2. I can divide 18 by 6. I'm going to get 3. So having said that here, I can write 2 pi. And you want to know fractions, guys. And let me tell you something. Some people who don't do so well in trig is because they struggle with fractions. So when I do fractions, I will try to emphasize things a little in detail. And you want to make sure you follow or practice some fraction stuff. So this is 2/3 radian. 120 degrees is same as 2/3 radian. So theta is 2/3 pi radian, not 2/3 radian, 2/3 pi radian. Another important point, guys, sometimes you will see radian has a pi in it. Sometimes there won't be a pi. Radian is just a number, okay? Sometimes it'll have pi, sometimes it won't. All right, having said that, let's take it to the next. I'm going to save it here because we might need it. I'm going to go to the next page and do the main problem, okay? Keep one thing in mind. Theta is not 120. Well, it is 120, which is also 2/3 pi. And if you understand that, now the problem is fairly easy. You want to know S. You do know S is R theta. R is 3 meters this time, not feet. Theta is, I'm going to write 2/3 pi. Okay? If you write 120 and get something, you won't get, it won't be correct and you won't get your points. So fine, I can handle that. This is nice. 3 and 3 go away. The answer is 2 pi. Done. How bad was that? Not bad at all. So again, your answer should be 2 pi. And since your unit is in meters, you can just write M. That's your answer. So here's a hard one that involves the formula S is equal to R theta. I'm pausing here just a little bit, okay? All right, guys, let's move on and do a couple more from our book. All right, you're gonna see it's very, very similar. Now I'm gonna do, let's do a hard one, okay? 87 through 90. Find the length S and the area A, round your answer. So this time they want you to find the area A. This angle is, let's do 90. Okay, I'll take 90 and bring it to my page where I do the work, but make sure you read the language. This is the same language I'm going to use when I design your exam. Okay, so you want to read it. So I'm going to just alert you regarding something. When you study, you know it's from chapter 2, section 1. But when I give you the problem on the exam, there's no way you would know. So make sure you read the language and you're familiar with the language so that when you see the same language, you don't panic. All right. So I'm going to do this one. It's one of the harder ones. Okay. And then next day, if you can do something, you come and ask me. I'll be happy to do it. I'm going to take this. They want us to find A clearly right here. Okay. So S, they're not talking about S. So I'm not going to be too worried about S. Okay, here's the problem. Number 90, they want us to find A The radius is 9, and that angle theta is 50 degrees. All right. And if you go through the same steps, I'm not going to go through it over and over. Hopefully that's okay. So you can show that 50 degrees is simply, let me think, is 50 degrees is simply 50 pi divided by 180. Okay. And that will turn out to be, let's put 50 here. It's all the same. It's not incorrect. And that would turn out to be 5. And you do want to practice, guys, okay? We can't, if you don't practice, you're going to get stuck. So 50 degrees is 5 pi over 18 radians. You can 5/18 pi, however you want to say it. The question is, I use the same technique. I started with pi is equal to 180, divided both sides by 180, and then I multiplied both sides by 50. This is what you're going to get. If you really want, I can write radian just to keep things straight. All right. So this is something you have to calculate. Fine. Remember that second formula right here, this one, A is equal to half r squared theta. We're going to use that because I'm looking for A. A is equal to half r squared, and don't forget the square, and theta in radian, piece of cake, half is half. R squared is 9 square. So let's put it in parentheses. 9 square. Theta, again, do not write 50. It's 5 pi over 18. Now, it's not bad, but you do have to do a little more work, and I would really encourage you to do it without using a calculator. Okay, 9 squared is 81 divided by 2, and don't forget your 5/18 pi. Okay, and if you really want, you can put a little multiplication sign. Now, 18 and 81 both are divisible by 9. And I would like to divide both by 9. Why? My numbers will be smaller. So how do I do that? When you divide 81 by 9, you get 9. You get 9. I'm going to do it here. A is equal to 9 over 2. Sorry. This. I know I made it a little too small. Hopefully not too bad. So I'm going to, well, now this gives me a little bit more room. I'm going to do it right here. Okay. 81 divided by 9 is 9. 9 divided by 2. Don't forget the 2. And 5 pi is 5 pi. 18 divided by 9 is 2. All right, things are already looking much better. Right? Now, on the right-hand side, I'm almost done. I multiplied the top numbers. 9 times 5 is 45. Divided by 2 times 2 is 4. And pi. Done. You can write 45 pi, or you can write pi next to 45. So either way, that's your answer. What's your unit? Since the radius is centimeters, area is going to be not centimeters, but centimeters squared. Okay, so if you really want to be formal, and you should be, centimeters squared. Okay, so that's your answer, 45 pi centimeters squared. I'm going to pause it just a little bit. All right, guys. So let's see. Now that takes care of all of these. These top ones are easy. They don't have a picture. The bottom ones have a picture. They're the same thing. You should be able to do them. Now let's try. Uh, well, here's what I'm thinking, guys. Let me try this problem. Okay, it shows you how to use some of these things in the real world, and that's not a bad thing to know. So, movement of a minute hand. The minute hand of a clock is 6 inches long. So the radius is 6 inches. You only care about the minute hand. Okay. How far does the tip of the minute hand move in 15 minutes? So it was here. How far does it move? Now, remember I told you you have to kind of know the meaning. If you don't know, you wouldn't know which formula to use. So you're talking about arc length. This is S. Okay. S is what this question wants you to find for 15 minutes and for 25 minutes. I'll do both and I'll do it very carefully. Okay, so again, for 15 minutes, this is going to be, by the way, this angle is 90 degrees. Okay, 30, 30, 30, 90, 30, 30, 90, 90 plus 90 is 180, makes sense. And I want theta to be in radian, okay? And using the technique that I have used, you can always show that theta is 90 degrees, sure. No question about that. That's going to also turn out to be pi over 2. I am interested in pi over 2, okay? I'm doing part A where the angle is 90 degrees and the time is 15 minutes. I'm doing this one. All right, guys, very easy. You remember, guys, you're talking about the tip and that's the arc length. You're going to use the S formula, and the S formula is S is equal to R theta. R is 6 inches. The question says so. And theta is pi over 2. And you might as well put a multiplication sign. And 6 and 2, they can be canceled properly. And you're going to get 3 pi. And the unit will be inches. And what did I do? I canceled these two numbers, this, and I got 3. So again, here's a word problem. Now you might say, well, nobody cares about a clock, how a clock tip of a clock moves. Well, the same math is used for planets. Okay, you don't want clocks, fine. This is the same technique that's used to find out how far the Earth would move around the sun. So trig is hard and it's very, but at the same time, it's very applicable. If you ever want to study astronomy or engineering or any physics related field, you're going to use a lot of trig. Okay, without trig, we can't find the radius of the circumference of the Earth or seasons or when the next eclipse will take place. So I'm giving you a little bit of background so that you know we're not doing it just because we feel like doing it. It has a lot of applications. So let me try the 25 minutes one, okay, guys? I'm going to do this one. Now, let me see if I can explain it. I don't need this. I'm going to write this. Take a look. This time, guys, 25 minutes would be 30, 30, 90, another 30, another 30. 25 minutes will be here. So that's going to be 30 plus 30 plus 30 is 90. 90 plus 30 is 120. 120 plus 30 is 150. So this time, you want to know what your theta is. It's 150. All right. You want to know what it is in radian. And that's going to turn out to be, if I'm not mistaken, let me think, 150 over 180. You do what I did, you're going to get this. And that can be simplified further. And let's do it here. I can divide both sides by 10 or get rid of the zeros. I will get 15. 15 can be divided further by 3, and you're going to get 5 pi. And 18 can be divided by 3. You're going to get 6. Let me double check. Make sure I didn't mess up. 150, I cancel the zeros. I cancel the zeros. And 15 divided by 3 is 5. 18 divided by 3 is 6. So that sounds about right. Okay, easy. Not really that bad. So everything is fine except for here. When I find S, my radius is still 6, but my theta is, let me grab it and put it here. Theta is 5 pi over 6, and that's some good news here. I can cancel the 6's, this 6 and this 6, and my answer will be 5 pi. 5 pi. That's my answer, guys. This 6 and this 6, they go away. Answer is 5 pi. You can leave it at 5 pi. You can use your calculator. Pi is 3.142 multiplied, but most people expect you to leave it as 5 pi. So I'll give you, I won't do this problem, but it's also a problem from your book. Same thing. It's a very nice example here. They're saying you have a sprinkler system and this angle is 135. What is the area of the lawn that's being covered? It's very, very similar. You probably want to try it. It's in your book. It's 2.1, number 95. And here is what I was thinking, guys. I won't start 2.1, 2.2 today. 2.2 has a very big idea. I want to start it when your minds are fresh. So I'll be happy to take some questions, and I don't want you to think like it's a short class and you're going to go home and have fun. You are going to do a lot of work on your own. Otherwise, you won't pass the exam. Okay. So in class, when we do face-to-face classes, we do these problems in class. So when we are doing lecture, it's a little hard to just cover the material. I can cover the whole book in 3 days, but if you don't understand, that's not going to help. So this is what I expect you to do. If you want to hang around, talk to me. I'll be happy to talk to you. If you want to, we will wrap up. We can talk about today's lesson. Do this, do that. Ideally from 5.1. Sorry. I'm teaching 3 classes. Ideally from 2.1. Of course, I'm not going to take too many questions from 2.2, but next class we will start. I was ready to do 2.2. 2.2 has a difficult concept, and it's I don't want to do it right now. We are almost like 1 hour into the lecture. Okay, so feel free to leave if you want to. This is what I'm gonna do, guys. Listen to me carefully. I'm gonna jump out of this session. Okay, I'm gonna quickly come back. Why am I jumping out? I'm gonna record this. I'm gonna hang around here at the same link, and I'm gonna upload it. I'm gonna go to your Blaze View page, upload the video, but I'll be here. So I'll see you either next class or the next session. Next session, if you come, I may not record. It'll be a one-on-one conversation. If you ask me to do a problem that I think, yeah, it's worth recording, I might record again. All right, guys. See you either tomorrow or next session. Thank you for coming. Bye-bye.